For example 1, we'd like to sketch a graph of x cubed times x minus 4. So I'll just rewrite that. F of x equals x cubed times x minus 4, but I'll actually put to the first power at the very end of it. And our goal is just to get a very basic sketch. So I won't really talk about how the y values, how big or small they are. It's just, again, something to give a general idea of what this graph looks like. So we're going to do this using the degree and also the zeros, the numbers, that is, that make your equation equal 0. So to start with, the degree is 4. What that comes from is, if you were to multiply this equation out, what is the largest power on x that you would end up with? Well, if there's an x to the third power, and over here you have an x to the first, if I multiply this into here, I get 4. I think of it as just taking 3 and 1 and adding those together, which gives me 4. So you gotta be careful. Since this thing is not expanded, you have to do a little bit of thinking as to what the degree is. For me, it was just 3 plus 1 is 4. Another couple of things to look for, again, is the zeros. And those are the numbers that when you put them in place of x, it gives you 0 back for y. It might seem like that's difficult to do, but if you look at this very first factor here, it's x minus 4 to the first. I know if you put 4 in place of x, 4 minus 4 is 0, and that actually tells me what one of the zeros is, positive 4. What that means is f of 4, I'll actually write it out, it's going to be 4 cubed, and then you have 4 minus 4 to the first, but when all is said and done, this is 0, which is why we call it a 0. The second number, there's another one, that is a 0, is actually the number 0 itself. Now that comes from this. If you put 0 in place of x and cube it, you still get 0, and 0 times anything else is also 0. So that is f of 0 equals 0 as well. We have almost everything that we need to complete our graph. I'm going to start by putting the zeros on the x-axis. There's one at 0, but there's also one at 1, 2, 3, positive 4. So these are 2 points on the graph. The second thing is the degree. Because the degree is even, I know the graph has to go up on the ends of the graph. Completing this example is just a matter of taking this side of my equation, going down to this point, and then figuring out what happens to get to this other side. So, step 1. This graph has to drop down to this point at 0, 0. There's 2 options. The graph crosses the axis, or it stays on the same side. Well, this 0 came from x cubed, and since 3 is an odd number, the function is going to cross over the x-axis, a lot like the graph of x cubed. So for just a small instant, this graph is x cubed, where it crosses over. Drops down a little bit, and then it comes back up to this point, and we're left deciding, does the graph cross over the axis or not? I mean, to me it looks like the graph does have to cross the axis for this to work out, but if you look at this term, this x minus 4 to the first, the 4 makes this thing equal to 0, so this point on the graph is referring to this factor, and since the exponent on it is an odd number, it's a 1, it means the graph has to cross over at this point. So I encourage you to go to Desmos or use your graphing calculator, but see if this is the graph or relatively close to the graph that you get. You might have to zoom in or zoom out to actually see a full picture, but this is what the graph of x cubed times x minus 4 should look like. So just to recap, I started by first plotting the zeros on the axis, which came from the numbers that made the factor 0. I then used the degree to determine that the graph went up on both sides, and the rest was just starting here, dropping down to this point on the graph, and using the exponent to determine that the graph crossed over the axis in both places because they were odd numbers. So example 2 is really similar to example 1. I just made one slight change. Instead of it just being f of x is equal to x cubed times x minus 4, I now put an exponent of 2 on the x minus 4 factor. So again, I want to list down what the degree is and also what the zeros are. And well, the degree is different this time. The degree now is 5. Again, that just came from, I can do it pretty quickly where I just add the 3 and the 2, which gives me 5. But really what this is saying is, if you square this out, you get an x squared, and if you distribute x cubed into that, the largest exponent you get is a 5. The next part's pretty easy. The zeros are exactly the same as what we had last time. One is 0, the other is 4, because I didn't change the factors. They still make the function equal 0. I think what I'll include this time is just note that, okay, well, the 0 at 4 has an even exponent, and this 0 has an odd exponent. I'll also keep that in mind. What this means is at the odd exponent it will cross, and on the even exponent it's going to stay on the same side. Let's see how this slight change alters the graph. I'll start by plotting my zeros. One is at 0, 0, the other is at 1, 2, 3, 4. But now, since the degree is odd, it's going to go down on this side, and it's going to go up on this side. All that is left to do now is just connect one side of the graph to the other by going through these 2 points. Before even drawing it, let's just kind of walk through it. The graph has to go up to this point, and since the exponent is odd, it has to cross over like a cube function. It then drops down to this point here, but since the exponent is even, it now stays on the same side. So I have a good idea of what this graph looks like. It goes up to this point, kind of levels off a little bit like x cubed, but eventually crosses over. It then goes up some amount, but eventually has to drop back down. And here, since the exponent is 2, I mean, the graph actually looks like x squared for a little bit. It actually resembles the x squared function, which is why if you see an exponent of 2, you could think, well, it should look like a quadratic. But here's my equation. Again, you could check this on your calculator or on Desmos. Again, you might just have to scale the graph so you see a good picture of it, but this is a general idea of what this polynomial looks like. And for the last example, again, same idea. I want to sketch a graph of this polynomial using the degrees and the zeros, but I threw in this other idea of how can we adjust this function so it takes on a particular y value at x equals 0. But we'll start the same way. If I look at this equation, what is the degree? Again, if I multiply all this together, what is the largest exponent on x? It's going to be 1 plus 1 plus 2, which is 4. If you multiply all this together, you're going to get an x to the 4th. So I'll put a 4 here. And the zeros are going to be different than in the previous examples, but we're approaching it the same way where if I look at this factor, I know negative 5 makes it 0. If I look at this factor, I know negative 1 makes this 0. And if I look at positive 3, it'll make this factor 0 as well. So I'm just going to list those numbers out. Negative 5, negative 1, and 3. I'll also label below it, okay, since the exponent here is a 1, I know it's going to cross. Again, the exponent for this 0 is 1, so it should cross as well. But the exponent for the factor of x minus 3 is a 2. This is even, so it's going to stay on the same side. So from here, I'll just plot these zeros, label what the degree is, and go from there. So I have a 0 at negative 1, 2, 3, 4, 5. I have another 0 at negative 1, as well as a 0 at positive 1, 2, 3. Since the degree is 4, it's going to go up on both sides, and now I just have to connect the left side to the right side. So I'll just jump right to that. The graph has to jump down to this point, and here's -5, where it has to cross over the axis. Now, it eventually has to come back up. Again, how low it goes, I'm not really too sure, but it has to go back up to this point where it's going to cross over the axis. It then has to drop back down. The only way this is going to work out is if the graph stays on the same side of the axis. But it does, since the exponent is even for x is equal to 3. And this should be an approximation of your graph. I actually did try typing this into Desmos, and I had to scale it a lot to see it pretty well. Like, I think I put the minimum value at -10 to +10 and left the y values to be just very large, and I was able to get a good picture of the graph. But you could experiment around with that a little bit. There's a lot of options that do work, but this is the graph of the function. Okay, final thought on this problem is, if you put 0 in place of x, you can do this computation yourself, but you do get 45 back for y. What that means is the y value here currently is 45. How could you adjust the original function so that you change it from 45 down to 9, but so you do not change the zeros or the degree? So there's a very simple way to do this. I think I'm just going to list it out, where if you have f of 0 is equal to 45, but you wanted it to be 9, well, you could multiply both sides by 1/5, because 1/5 of f of 0, or 1/5 of 45, is in fact +9. So all this means is, if you go to your original function and you multiply the whole thing by 1/5 and leave everything else alone, then we've accomplished this goal. By putting 0 into this function, you're going to get 9 back for y. Because I'm multiplying by a number, it does not change the location of the zeros, and it does not change the exponents, which means the degree does not change either. So that is it for example 3. And again, just try to check these graphs in Desmos or on your graphing calculator.